All right, so we're on our third video and we're talking about graphing linear functions 1. Okay, so these are the notes to help you accomplish your mission, which is to answer the questions on graphing linear functions 1 worksheet. Okay, so let's dive in here. All right, graphing linear functions. The first thing we want to talk about is the linear parent function, which is y equals x. It goes through the origin, right, at 0, 0. It has a slope of 1. We go up 1 and over 1, up 1 and over 1, up 1 and over 1. It's positive, right? And then every other line is a child of this parent function. In other words, every line that we come across can be written in terms of y equals x. And we'll talk about some of those transformations later. So today we just want to look at how could I graph if I have an equation. So what we want to do is we want to make sure that the linear function is in what we call the slope-intercept form. Okay, slope-intercept form. It's called the slope-intercept form because M, right, stands for slope. The B stands for the y-intercept. Now, when we were graphing our linear equations before, or linear functions, we wrote them in terms like this. We said f of x, and then if you'll recall our situation with Susan and her grandmother, she saved $34, and then she continued to save $2.50 each week. Okay, so that was our linear function. Notice here, this was the amount we began with, and this is how much we were saving. That was our rate of change. So this is just alternating that, and you're allowed to do that because addition is commutative, right? So we can move these two, and it's the same function. So if you wanted to, you could write y equals b plus mx, and you would be totally okay on that as well. It's just kind of whatever you like. All right. So when you look at these equations, the b, right, is always of the form 0b because the y-intercept, remember when we're on the y-intercept, all of our x values are 0 because this point is 0, 0, our origin. And since we're not leaving that, we're just going up or down the y-axis, all of our x's are 0. Okay, so, and then b is whatever the number is. So, what we can do is once we figure out what the y-intercept is from the equation, we can plot it on the graph, and then we can use the slope to move. And the suggestion here is 2 points. I go as many as it takes. All right, so let's take a look. Okay, here's our formula. Y is by itself. Here's our x term. Here's our constant. Okay, so if we're using the y equals mx plus b, then m would be located here, plus b. Okay, now we have a plus sign, so that means that minus is going to go with the 3. Okay, so our b value, our b coordinate is 0, -3, and our slope is positive 1. I know that because there's no number written in front of the x, so the only number that could be there is 1, because 1 times x is x. All right. So now that I've pulled that information out of the equation, I come to my graph and I count to the point 0, -3, 1, 2, 3. I place a point. My slope is 1. That means I'm going to rise 1 and run 1. Okay. Now, for those of you who don't know how I was able to do that, 1 is a whole number, but to turn it into a fraction, I can put it over 1 because that doesn't change its value, right? I'm dividing by 1, I still have the same thing I started with. Okay, so 1 over 1 means I'm going to go up 1 and to the right 1. I know I'm going to the right because this is a positive slope, and remember, positive slope went up. If it was a negative slope, right, it goes down. All right, so we're going up 1 to the right 1, up 1 to the right 1. I like to put lots of points down because I think that gives me a better, more accurate line. Okay. I will ask that you put at least 2 points. Okay, and see, once I've got all those points on there, it's really easy for me to do my line feature. Okay. And just draw through the points. Okay. All right. So that is y equals x minus 3 graphed. Oh, and I want you to do me a favor. I want you to label your grids and graphs because, you know, it's important. They need names. Okay, let's look at another. Y equals 3/4 x. Okay, so y is by itself. So if I put down that y equals mx plus b, m is 3/4. There's my x. There is nothing written out here. Is that a trick? What's up? What can I add that's nothing? That, well, it kind of doesn't change the value, right? I can add 0. So that means my b value is going to be the point 0, 0, and my slope is 3/4. So I go to my grid and I put 0, 0 as a point, and then I will count. So it's positive 3/4, so I know I'm going up and to the right. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2. Can't go that way. Let's try this way. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay, so that's all the points I can plot on this particular grid. I'll pick up a line and I will draw my line through my points. Yay! And then I will label my graph. Y equals 3/4 x. All right, let's look at another one. Y equals negative 2x plus 1. Okay, so I'm going to put y equals mx plus b. M is negative 2. B is positive 1. So B is the coordinate 0, always, comma 1. And then M is negative 2. I'm going to go ahead and write it over 1 because I know I can divide it by 1, and now it's a fraction form. Okay, so let's put that together. 0, 1. That's where I'm beginning. Negative 2, 1. Okay, I know a negative slope is going to go like that, so I'm going to go up 2 and to the left 1. Did I confuse you because I went up and to the left? Well, negative 2, 1, I could have gone down 2 and to the right 1. Lines are continuous in both directions, so we have to be prepared to move either way. Okay. All right, so now I've got all possible points on there. Grab my line and connect the dots. All right, and then I want to label my line. So this is y equals negative 2x plus 1. I think I'm getting the hang of this. Let's go on and try another one. Number 4, y equals negative 5. So I go y equals mx plus b, and there is no thing for the mx term, okay? But b is negative 5. So I know b is going to be 0, negative 5. But what do I do about the slope? So I have to think about that. If the x isn't even there, then the slope and the x together have to be 0. right? Because nothing is written there, so that's a value of 0. Well, the only way that's going to happen, because x could be anything, that means that the slope had to be 0. Okay, so the slope is actually 0. So if I go to the point 0, negative 5, let's see, 1, 2, 3, 4, 5, and then I have a 0 slope, so that means I don't rise. Oh yeah, remember when that first day we talked about slope? A 0 for slope meant it would be a horizontal line. And that's where the slope dude said that was 0 fun. Okay, so I just have a line. So that is y equals negative 5. Okay. All right, let's see what else they got for us. They got a little tricky on that one, but we saw our way through it. All right, number 5. X equals 1. What? X equals 1. Oh, note different. Well, I'd say it's different. There's no y. How do we do? Y's got to be here. We can't have nothing equals x and 1. That makes no sense. All right. So this is the one case that always seems so weird. So I'm just going to go with it this way. If x equals 1, and I go to the x-axis, x equals 1 right there. You see what I'm saying? Okay. And then there's no other information, so that means it's undefined. So if our m is undefined, that means that we're going to have a vertical line. So the x equals 1 tells us an x-intercept is 1. Our slope is undefined. We have a vertical line going through 1 on the x-axis. Well, they saved that one for the last. All right, so that should be all the different things you're going to be required to do on the Graphing Linear Functions 1 worksheet. So y'all go get after it.